Hi everyone and welcome to my channel. I'm Eugene and this channel is dedicated to teaching of programming and software development. This is the ninth Programming Fundamentals lesson, and in this lesson we are going to learn about functions in C#. I must say that in C# functions are called methods, and you will understand why in one of the next lessons. But for now, let's talk about the ideas behind functions or methods, and we'll leave the name for later. First, let's understand what methods are and why we need them. Let's take a look at an example from life. Consider you want to prepare yourself a cup of coffee. Normally, you would do the required steps yourself, like putting a spoon of coffee into the cup, boiling water, then pouring the water into the cup and mixing it. And every time you want to prepare coffee, you have to remember these steps and do them without mistakes. Now, imagine that at some point you decided to buy a coffee machine. The coffee machine does exactly what you manually do, but for you it becomes as simple as pressing a button. Now, there are a few benefits in preparing coffee using a coffee machine. First, in contrast to preparing coffee manually every time and doing the same steps time after time, you simply press a button on the coffee machine and it will do the required steps. This means that the coffee machine is reusable. Someone created the machine and you can use it time after time without manual steps. Second, you don't need to remember or even know the steps. You just press a button and the coffee is ready after a while. You don't need to know how it works. You use the coffee machine as a black box without even knowing the steps of preparing a coffee. Now, what you should know is how to use the coffee machine. You should know which button to press to prepare the desired coffee and what the coffee machine needs to get in order to prepare it. Then the selected coffee will be ready at the end of the process. Now, let's take the idea of a coffee machine to programming. A method in C# is a block of code that performs a specific task and can be called when needed. And you only need to provide the method with the input it requires and it will return the output that it produces. Just like with the coffee machine, you only write the method once, just like someone prepared the coffee machine, and then you can call that method whenever you need it. You don't need to write the commands of the method every time. Instead, you can call the method just like you press a button on the coffee machine. In other words, methods allow us to reuse pieces of code that do a specific task. Second, just like with the coffee machine, you don't have to know how the method works. Someone could write it for you and you just call it without knowing what it does internally. A method can be just a black box for you. And just as you need to know what to give the coffee machine and what it will produce, you should know what your method gets as input and what it returns as its output. Now, one important benefit of using methods in programming is that if you write the same code multiple times, you might do different mistakes every time you write that code. So it is better to write the method once to minimize potential mistakes. And if you found a mistake in those commands, you will need to fix the mistake only in the method. Let's see how we write methods in C#. The structure of a method is like this. First, we have the return type of the method, which means what the method will return. Then we have the method name, using which we call the method. And then we have the parameters that the method gets. After that, we open a block using curly braces, which is the body of the method, and it contains the method's commands. The body is like a small program that does a specific task. Now, if the methods return something, the body should contain a return statement that returns a value that corresponds to the return type. For example, let's take a look at a method that adds two numbers. As you can see, its name is add. It gets two parameters of type int with the names a and b, and it returns an integer. Then we have the body of the method that calculates the sum of the two numbers. The last line of the method is return sum, that returns the result of the calculation. A method doesn't have to get parameters. In this case, the name of the method will be followed by opening and closing parentheses. Also, a method doesn't have to return anything. In this case, it returns void. Void means that the method doesn't return anything. Notice that the return keyword can still be used, but this time it will not return a value, but the method will just exit. We will see examples later. To call a method, we do the following. We write the name of the method and we give values for the parameters in parentheses based on the order of the parameters. For example, you can see that we call the method add that we wrote before. As you can see, when we call the add method, we give it 1 and 2 as the parameter values. The values go to the parameters based on their location. Number 1 goes to parameter A, and number 2 goes to the parameter B. Since the method add returns a value, we can assign the value it returns to a variable, in this case, result. Later we print that result in our main program. When we call a method, the program runs until the place where we call the method, then continues inside the method, and once the method finishes, it continues from the place right after calling the method. As we said before, a method can return a value, but it is also possible that it will not return anything. In this case, the method returns void, like in the first example that you see. As I said before, we can use the return keyword even when the method doesn't return anything. In this case, the method will just exit, as you see in the second example. As you can see, the method can exit at any point using the return keyword. Even if we have more lines of code in the method, it will exit when it runs the return statement. Also, we may have multiple return statements, and the method will exit when it reaches one of them. In the previous example, we used the return keyword to exit from the method. In this example, the method returns an integer and we use the return keyword to return a value. However, pay attention that the lines that calculate 4 plus 5 and console write line are not going to be executed at all, because the program will be already out of the method at that point. In this specific case, the value of num just won't be printed. Again, we may have multiple return statements in the method for different scenarios, for example. Just like in the main program, we can declare variables inside the method. However, those variables are local to that method. They can be used only inside it. Code outside the method can't access them. Moreover, when the method finishes running, all of its local variables are discarded. They stop existing and their values are lost. How can we distinguish one method from another? Of course, the name of the method is one of those factors. But what if we have two methods with the same name? In such a case, we can distinguish between them by the parameters they receive. Not the name of the parameters, but their type, number of parameters, and order. This combination is called the method signature. It's what defines a method in a unique way. The signature contains the method name and the parameters, their types, number of parameters, and order. Notice that the return type of a method is not part of the signature. Now, since two methods with different parameters are considered two different methods, it means that we can define two or more methods with the same name as long as their parameters differ in some way. This is called method overloading, when multiple methods share the same name but have different parameters. Now, this works when defining methods within classes, and we didn't learn about classes yet. So we'll see examples when we learn about classes. Still, it was important to talk about method overloading at this point. In the example you see, we have two methods named add, but since one takes integer and the other one takes doubles, they have different signatures, so they are considered two different methods. And because of that, we can easily define those two methods in the same class. Again, we'll get back to it when we learn about classes, but you already know the idea of method overloading. Now, just a few words about method naming. By convention, method names in C# start with a capital letter and use Pascal case, like calculate total that you see. Pascal case is a naming convention in which each word starts with an uppercase letter and there are no spaces or underscores between the words. There are actually more topics to cover when learning about methods, but since our course is aimed at beginners, we will leave those topics to a more advanced course. For now, let's go to VS Code and see some examples of writing and calling methods. Alright, so now we are in VS Code and I already created a console app. Now, as a first example, let's try to write a method that simply prints numbers from A to B, while A and B are the method's parameters. So, first, since the method only prints numbers and doesn't return anything, we'll begin with writing void as the method's return type. Then we'll give a name to the method. Let's call it print numbers. And then we should define the parameters that the method gets. In this case, it gets an integer named A and an integer named B. Alright. Now we start writing the method. And as I said, we want to print the numbers from A to B. To do this, we are going to walk over all the numbers from A to B using, for example, using a while loop and print every number. Alright. So let's do it like this. While A is less than or equals to B, first we are going to print A. We'll just add a space after every number. And then we need to increase A. Otherwise, it will never get to B. Alright, so I think that's all. Now, as you can see, I'm using A as if it was a local variable. I can work with these parameters inside the method. Alright, now let's call the method and see how it works. So first, to call it, we simply write the method's name, and now we give values to those parameters. For example, let's type 4, 8. All right, and let's run the method, the program. All right, so as you can see, it's printed, but that's not what I meant, actually. The reason I added a space here was because I didn't want to print a number in every line, but I wanted all numbers to be printed in a single line. Let's try again. And now, as you can see, all numbers are printed in one line. 4, 5, 6, 7, and 8, because it is less than or equals to, so B is also printed. All right. Now, let's write another method. This time, a method that receives two integers and returns the average between those integers. All right, so let's delete this. And now, if the method returns the average between two integers, we understand that the result might be not an integer. It might be a double. So the method will return a double, and we'll name it calculate average. All right, now it gets int a and int b. Okay. Now what the method needs to do is actually, first it needs to sum those two numbers and then divide by 2. All right, let's do it. So we'll declare a variable named average and do something like this. A plus b divided by 2. And then we'll return the average. Now, there is a mistake here, and I intentionally wrote it because I want to show you just one more time how it works when we have integers and, for example, we need to return double, how conversions work. All right, now let's try to call this method. So first, let's declare a variable of type double named result, and we'll assign the result of the method to that variable. So we are calling the method, and the result that it returns will be assigned to the result variable. Okay, and the values we'll give it will be, let's begin with something that should work. For example, 2 and 8. All right. And now let's print the result. Okay. Let's see what happens. So the average is 5, which is correct. But what if I try to calculate the average of 2 and 7? Let's see what happens. This time we are getting 4. But that's a mistake, as you understand. So what's the problem here? The problem is that when we added two integers here, we got an integer. And when we divided the result integer by 2, we actually did an integer division. That's why average is an integer value. So in order to make a division of double and not an integer division, we need to make sure that at least one of those parameters is a double. To do this, we simply can convert a to double. And now, since a is a double and b is an integer, the result of the addition will be a double. So after dividing it by 2, we will get also a double and not an integer. Alright, let's try running this and we'll see what's happening. Okay, and this time, as you can see, we get the correct average. Now, the last thing that I wanted to show you is how variable scope is working when we work with methods. So let's write another method. This time, a simple method, just a method that will print the sum of two numbers. So it doesn't return anything, which means it returns void, and we'll call it print sum. All right, it will get int a and int b. Now inside this method, we are going to declare a variable named sum. And then we'll print it. All right. So, as you can understand, if I call this method with the values, for example, 1 and 2, we will see that 3 is printed. All right, so the method works, which is good. But now, what if I want to access this sum variable here? Let's try it. For example, I'm trying to print the sum variable. Okay, so as you can see, even VS Code shows me that something's wrong here. And if we look at what is wrong, then it says the name sum does not exist in the current context. This is because sum exists in the context of this method, and it was discarded the moment that the method finished running. Alright, so in this lesson, we learned about functions or methods, as they are called in C#. Thank you for watching, and see you in the next lesson.